All right, here's notes 1-4, characteristics of functions. So in the previous lesson, we learned about our function families, and now we're going to talk about how we discuss the characteristics of functions. So the first way we might describe a function is whether it is continuous or discrete. Most of the graphs that we've looked at so far have been continuous. A continuous graph is completely connected. There are no breaks or holes. A discrete graph is going to be disconnected. Usually you'll see it as kind of like a bunch of dots in a row. And there might be breaks, holes, or gaps. So here's an example of a continuous linear function. It might be just a line going straight with arrows on each side. As we can see, it's completely connected throughout the whole entire graph. The discrete version of this graph would basically be dots following a linear pattern. And that would be an example of a discrete graph. So it still can continue from left to right, but instead of it being completely connected, there's points or dots. So here's an example. This is a continuous graph. I know that because it's not connected. I just see dots at various points on the graph. But as we can see here, it still follows somewhat of a shape. So to determine what function family, if I were to kind of connect the dots, I see that this is a curve that kind of flattens out. This would be an exponential function. Graphs can also have a minimum or a maximum. So in terms of the graphs that we've talked about, the only graphs in our function families that can have a minimum or maximum is going to be a quadratic function or a linear absolute value function. So a minimum is the lowest point on the graph and a maximum is the highest point on the graph. So on the left, I'm going to draw an example of a graph that has a minimum. For this one, maybe I'll do a quadratic. So quadratic would look something like this. We know quadratic is U-shaped. We know that it has a minimum point here. Our quadratic can also face in the other direction. In that case, it would have a maximum point. The other type of graph that can have a minimum or a maximum is a linear absolute value function. So we know that that is V-shaped. And if we want it to have a maximum point, we know that it's going to be facing down. So it might look something like this. So this point would be the maximum. The two other types of graphs we talked about, exponential and linear, are not going to have a minimum or maximum. Those are either going to keep increasing or decreasing, which we're going to talk about in a second. So the only graphs that have a minimum or maximum are going to be a quadratic or a linear absolute value function. All right, so this is a quadratic function. It is facing down. This one has a maximum point. As I mentioned, this is a quadratic function, and I know that because it is U-shaped. Okay, so we can also describe functions as being increasing, decreasing, constant, or a combination. So increasing function goes up as you read from left to right. So the function that's easiest to determine as increasing might be a linear function, which would look something like that. That would be considered an increasing function. But another function that just solely increases would be an exponential function. Exponential function would be kind of flat, and it goes up. And the key thing to remember, we're always reading from left to right. So looking at our graph from left to right, we know that is increasing, because if you read from the other direction, it would look like it's decreasing. So we're always going from left to right. A decreasing function, it goes down as you read from left to right. So just like I did before, a linear function is pretty easy to tell. It's when it's decreasing, we're reading from left to right, it's going down. But in terms of an exponential function, it would look something like this. It's a curve going in a downward slope. So referring back to the previous one that we talked about, that we said that the only functions that have minimums and maximums are linear absolute value and quadratic. It might be tempted to say, oh, well, this has a minimum, but really what's happening is this is going to continue going down, 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 very, very close to zero, but it's never going to touch zero. We'll talk more about that in a later unit. Okay, a function can also be constant, meaning the y value does not change the entire time. In that case, it would just be a horizontal line. So that would look something like this, just a horizontal line going from left to right. We can also have a combination of increasing decreasing, and constant graph. So one example of a combination is a quadratic function, right? A quadratic function we know is U-shaped. We know that the side that it is increasing on is the right-hand side, because again, if we're reading from left to right, this is the increasing side. And then if we look at the other side, that function is decreasing on that side. So this is an example of a function that is both increasing and decreasing. It decreases first, going down, and then once it hits to the minimum point, it starts increasing. So this is an example of an increasing linear function because it is going up from left to right. And this is an example of a decreasing exponential function because from left to right it's going down. Again, it looks like we have a minimum value, but like I said, it's going to get very, very, very close to the x-axis, so 0, but it's never going to touch 0. All right, so now we're going to look through these functions and classify them based off of various characteristics. So looking at number 1, this would be considered a function because if we do the vertical line test, our vertical line is never going to touch my quadratic more than once. So this is a function. Because it's completely connected, there are no breaks or anything. We're going to say that this is continuous. In terms of deciding if it's increasing, decreasing, constant, or a combination, if we read from left to right, we see that on the left-hand side, it goes down. And then once we hit that point, it starts going up. So this is actually going to be a combination of increasing and decreasing. The left-hand side is decreasing, the right-hand side is increasing. This graph has a minimum value. And then in terms of the function families, this is V-shaped, so this is a linear absolute value function. All right, looking at number 2, like the previous one, doing the vertical line test, if we draw a bunch of vertical lines, it's never going to touch our function more than once. So this is a function. This one is discrete because it's dotted. To decide if it's increasing or decreasing, we go from left to right. That function is increasing because it's going up. This particular function does not have a minimum or maximum because we know it's going to continue going on in that pattern. So that's going to be neither. And then what function family does this belong to? This is a line, so this is going to be a linear function. All right, number 3, this is a function, passes the vertical line test. We draw a bunch of vertical lines. It's never going to hit my quadratic more than once. This is a continuous graph. There are no breaks. Going from left to right, if this were a roller coaster, we would be going down. So this is a decreasing function. This graph, like I said many times before in this lesson, it might look like there's a minimum value, but it's never actually going to hit a single number. So this is going to actually have neither. And then the function family for this one is exponential. Exponential is when we have a curve that flattens out on one side. All right, the next set of problems, we're sketching a graph that has certain characteristics. So this says we want a graph that is linear, discrete, and decreasing over the entire domain. So discrete means that it's going to be dotted. We know that linear means that it's going to be some type of line either going up or down. But since it's decreasing, we know that it's going to be going down. So that might look something like this. All right, the next one says it's quadratic, which we know is U-shaped, so up or down. It's continuous means it's connected. It's a smooth curve, not a bunch of dots, and it has a maximum. So if it has a maximum, we know that it's going to be facing down. So that graph might look something like this. All right, this last one is exponential. So exponential either looks like this or like this. It's continuous, which means we know that it is a smooth curve or smooth line, but it's going to be increasing over the entire domain. So increasing from left to right, that's going to be the one on the left. So that light might look something like this. All right, now I'm going to go over a couple of the homework problems. So starting with question number 4. So this one says, oh, I think that's number 4. Yeah, question number 4, my numbering's got a little funky. So same thing that we were doing before. We're going to determine if it's a function or non-function. So this is going to be a function because it passes the vertical line test. It's continuous since it is a smooth curve. Going from left to right, that is an increasing function because it's going up. This function has neither a minimum nor a maximum. And then the function that is kind of a smooth curve that flattens out on one side is going to be exponential. All right, so question number 7, I don't know why my formatting's a little off, but has an absolute maximum, is continuous, is symmetric, and is curved. So number 1, I'm looking at that it has an absolute maximum. So that means it could either be like this or it could be V-shaped. But since the last thing says it's curved, we know it's probably going to be a quadratic. It also says it's continuous and symmetric. So symmetric is something we didn't talk about in the lesson, but symmetric basically means that you can cut it in half and it's going to look the same on both sides. Well, both of these types of graphs are actually going to be symmetric if you cut it in half. So this is going to be a quadratic function that faces down. So let's just check the characteristics. It has an absolute maximum. That's correct. It's continuous. It's a smooth curve. It's symmetric, which means that we can cut it in half like so. And it's curved, which it is.